Okay, now we are going to talk about something related to numbers, and this is a very important function you see, which is called floor function, and the opposite is ceiling function. So the notation is like this: you draw a bracket, but you remove the top. That means you draw a bracket, but you don't draw the top. This is called floor. The ceiling is the opposite. You draw the ceiling, and then you just okay. The meaning of the floor function, just by the name, you take the integer on the nearest to x that is below x. For example, 2 is 2, 2.4, the nearest integer is 2, below 2.4, okay? 2.001, the integer below 2, this number is 2, okay? 2.9, the integer below this guy is 2. Negative 2 is negative 2 because 2, okay, because of this, okay? And then negative 2.01 is negative 3. Negative 2.999 is also negative 3. Pi is 3.13 something, okay, so therefore it's 3. Negative pi is 4, okay? So this is the floor. You can also have the ceiling, and this is the graph, okay? So here's some funny, interesting combinatorics problem. How many integers from 1 to 2001, so this is a mistake, okay, are divisible by 3 or 4 but not 5? Here's an answer. How do you approach this kind of question? Here's the approach. So let's say we have 1 to 20. The question is how many number in n are divisible by 2 or 3? So what's the first solution? The first solution is brute force. So you write down 1, 2, 3. Divisible by 2 or 3, right? So divisible, yes, yes. Yes, yes. So you count how many ticks, then that's the answer. This is the brute force, which is a not efficient approach. So what about a better approach? The better approach is to make use of inclusion-exclusion principle. So let A be the set in n that are divisible by 2, and let B be the set in n that are divisible by 3. Then we have the size of A is 20 divided by 2 floor, that is 10. Okay, B is 20 divided by 3 floor. 20 divided by 3 is 6 point something, and take the floor is 6. So A is 10 and B is 6. So think about it. In 20, how many even numbers are there? 10, right? So 10. In 20, how many numbers are divisible by 3? Well, it will be 3, 6, 9, 12, 15, 18. So there are 6 numbers. Okay? So that's it. Okay? Then how many number of them are double counted? So A and B is the set of integers that are divisible by 2 and 3. Okay? Divisible. I missed the word divisible, okay, which is 6. So A and B will be 20 divided by 6, which is 3.3 something. Take a floor at 3. So what are those numbers? 6, 12, 18, okay? And then by inclusion-exclusion principle, set A or B will be A plus B minus A and B. So 10, 6, 3. Give me 13, okay? The second example, okay, how many integers from 1 to 100 are not divisible by 2, 3, 5? So we can find the number of integer divisible by 2, 3, 5, and then not we take the complement. So it will be the set of 1 to 100, okay, subtract the set of what? Divisible by 2, 3, 5. And let's say the set are A, B, C, okay, by 2, by 3, by 5. So the first thing to do is to find A, B, C. This is a what? A or B or C. And this is what? 3 sets. So inclusion-exclusion principle, this, okay, then we have to count the numbers. So what is this thing? This is the number of integers divisible by 2. So in 100, so 100 divided by 2, which is 50. Floor 50 is 50. What is B? B is the number of integers within 100 divisible by 3. So 100 divided by 3, which is 33 point something. Take the floor, give us 33. What is this? Number of integers in 100 divisible by 5. So 100 divided by 5, there are 20 of them. Take the floor is still 20. Okay, what is A and B? The number of integers divisible by 2 and 3 at the same time. So 2 and 3 at the same time. So that means divisible by 6. So 100 divided by 6. Take the floor, it gives us 16. What about this? This is number of integers divisible by 2 and 5. So that is divisible by 10. There are 10 of them. So that's why there's a 10. What is this? This is the number of integers divisible by 3 and 5. So that means 15 divisible by 15. So divisible by 15, which is this number. And what's this? Number of integers divisible by 2 and 3 and 5. That means divisible by 30, okay, which is 3, okay? Basically 30, 60, and 90, right? Okay, so you get all this number, then you count it. There are 74 number in 100 that are divisible by 2 or 3 or 5. And then the not will be 100 minus 74, that's 26. So that's how you solve it. And lastly, we will talk about basic counting principle for counting password. So suppose you have a password that is between 6 and 8 symbols. That means you have 6 boxes Okay, 6 boxes to 8 boxes. And then the first symbol must be a letter, lowercase or uppercase, and the remaining symbol can be letter or digit. How many passwords are possible? So we will let F be the first digit. And because the first letter can only be English alphabet, so it's A to Z and A to Z. The other digits can be letters or digits, so it will be A to Z, and 0 to 9. So that means the first guy is F, and all the other are S, 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 S. Okay, so this is 6-letter password. The first letter has to be F, so F. The other 5 are from S, so it will be times S power 5. This is length 6 password. This is length 7, so it will be F times 6 boxes containing the letter from S, so S to power 6. This is length 8, so it will be F times S to power 7. So these are all the possible passwords. How many passwords are them? We take the union and then take the number of set of this guy. They are disjoint, so we get some rule. Not inclusion, exclusion, visible, because they are disjoint, so we don't need to count about their intersection. So we get this, and then by product rule, this Cartesian product become a dot. So we count each of them. F is what? F is basically all the English letter, no number. So there are 26 small letter, 26 capital letter, so 52. What about S? S is from A to Z, and then 0 to 9. So 26, 26, and 10. So it will be 62. Okay? And then this guy have 5 times, so power 5. This guy have power 6, so this guy have power 7. Okay, so I make a mistake. This should be power 6. Okay, it will be some number. Okay, and then here some funny thing, basically saying that you have a lot of password, and because you have a lot of password, the chance of guessing it correctly is very low, and you are more likely to get hit by thunder than guessing a password. Okay.